In 1954, Britain finalized Specification ER.134D, calling for the development of a supersonic aircraft that would be the fastest in the world behind the US X-15 spaceplane project. The aircraft would need to maintain speeds of at least Mach 2.75 for prolonged periods, necessitating the exploration of radical designs capable of dissipating the extreme temperatures generated by atmospheric friction. Judged to be the most promising of the submitted proposals, the Bristol Aeroplane Company was awarded a contract to create 6 of their Bristol Type 188 airframes. The experimental stainless steel twin-engine jet plane would be built specifically to avoid kinetic heating of up to 500 degrees Celsius that would melt traditional aircraft. The expensive, complicated, and unusually thin design earned it the nickname the Flying Pencil. Supersonic flight. The 1950s were marked by the new possibilities offered by jet development. Supersonic flight was an innovation that was becoming standardized for new military aircraft. The first flight of the English Electric Lightning in 1954 broadened the opportunities for the United Kingdom, for it regularly achieved speeds that surpassed Mach 2, twice the speed of sound. Still, the development of supersonic aircraft introduced several challenges for designers, engineers, and pilots. While the speed of sound had been surpassed in 1948, the effects of flying at that speed were not yet well understood. Operators had many more questions than answers. In an attempt to resolve curiosities and to achieve air dominance, the Royal Air Force launched Specification ER.134D, which called for an aircraft capable of sustained flight at speeds surpassing Mach 2.75. They primarily wanted to learn about kinetic heating and maintain a safe airframe for pilots while providing maximum speed. Should the requirement produce a successful plane, the British would own the second fastest aircraft in the world at the time, following the United States X-15 spaceplane. Development. The Type 188 tried to follow Specification ER.134D, which asked for a high-speed reconnaissance aircraft. Their progress was intended to illuminate the preparations for Avro aircraft to build another plane, the Avro 730, to match the operational requirement 330 for a speed of Mach 3 or more. Since the Avro 730 would have to operate at supersonic speed for prolonged periods, the Britons needed more data on high-speed operations. Mainly, the project was supposed to provide conclusive data on the kinetic heating effects of a plane that would spend significant time with a skin temperature of around 300 degrees Celsius. At first, several aircraft companies were interested in working on the advanced specification. Still, in February of 1953, the contract was awarded to Bristol Aircraft. The company labeled the project 188 and planned for the construction of 3 planes, 1 to serve as a test bed and 2 flight testing aircraft. The aircraft intended for flight tests were referred to by their serial numbers, XF923 and XF926, granted at the start of January 1954. After careful deliberation, it was decided that the development of the advanced aircraft would require new construction methods. Specialist grades of steel were selected, an austenitic titanium steel and a chromium mixed steel. Manufacturing them with better tolerances was the first challenge the project had to overcome. The chromium mixed steel was used for the outer skin, applied with a modern technique known as puddle welding. The method delayed development and offered unsatisfactory results. Bristol heavily relied on technical assistance from the W.G. Armstrong Whitworth Company, which was subcontracted to produce considerable sections of the airframe. To maintain the cockpit as a stable and cool environment, they decided to create a refrigeration system with fused quartz for the windscreen, canopy, and cockpit. The system was fitted, but never tested. The aircraft needed engine installations that welcomed different engine types, propelling nozzles and air intakes, which delayed the process again. The Type 188 was initially supposed to use Avon engines. Instead, lighter Gyron Jr. engines were used, meaning that they had to be mounted more to the front due to their longer nacelles and jet pipes. The choice of engine significantly reduced the aircraft's endurance to 25 minutes, far below the requirements for the planned high-speed research tests. Testing. The first aircraft, the XF923, was completed and delivered to the Royal Aircraft Establishment for static testing in May of 1960. In April of the following year, the plane was ready for engine tests. Unfortunately, the XF923 exhibited issues with the afterburner and the intake. Bristol spent a year working on these issues. To reduce the aerodynamic and flutter problems, several large-scale models were produced and tested. Some of these were mounted on rocket boosters and fired from Aberporth to test free flight capabilities. The plane was ready for flight in April of 1962. 8 years had passed since the original order. The 188 flew for the first time from Bristol to Boscombe Down in a simple transfer flight. The project suffered not only from the aircraft's increasing number of issues, but also from the postponement of tests due to construction challenges. Finding the right materials had proven more complicated than estimated. Puddle welding had to be developed for the panels, and the central wings had to be redesigned due to aerodynamic issues stemming from the tests on the models. The engines had also proven to be problematic. Once the two planes were ready to fly in 1962, the English Electric Lightning was already entering service with the desired speed of Mach 2. While the Type 188 planes surpassed the sound barrier without difficulty, neither could reach the Mach 2 speed set out in the requirement. Their best performance showed a speed of Mach 1.88 at an altitude of 36,000 feet. Godfrey L. Audie, the chief test pilot, stated that although the plane transitioned smoothly between subsonic and supersonic speeds, the engines would cause the aircraft to pitch and yaw. The aircraft's engine consumed fuel rapidly, resulting in only 2 minutes of high-speed flight. As the 1960s marked a change in focus from high-speed aircraft to missiles, Type 188 fell out of favor for the Royal Air Force. Meeting the requirements would have meant redesigning the engine bays, constructing new intakes, and replacing the engines. Too complicated. The complete flying pencil project had an estimated cost of 20 million British pounds, a staggering price tag when considering that it failed to meet the goals set out by Specification ER.134D. Despite efforts to continue modifying the aircraft, support for Type 188 was slowing down. The test pilot involved in the project had been given a jesting nickname by his peers, who assumed that the failed supersonic aircraft would eventually crash and burn. He was voted, quote, the man most likely to eject in the coming year. In total, 70 flight tests had been conducted. The fastest speed achieved was Mach 1.88, notably coinciding with the plane's name, Type 188. The longest subsonic flight had only lasted 48 minutes. The aircraft made its public debut during September of 1962 by flying for 4 days at the SBAC Air Show in Farnborough. Although the plane had achieved considerable speeds, these were practically useless because it could only maintain supersonic flight for limited periods. Overall, Type 188 had underperformed and disappointed. The project died off in 1964, the same year it conducted its last flight, on January 12th. The usefulness of the endeavor itself for research purposes was questionable. Although the British had gained knowledge of construction and specific materials, much of the data on supersonic flight was inconclusive. Avro 730. Part of the intention with the program for the Type 188 was to gather data that would help in the development of the Avro 730 aircraft. The test flight data collected from the 188 was transmitted directly to a ground station where it was evaluated and then shared with Avro aircraft. They would then adopt or eschew techniques when considering the high speeds and altitudes sought for their own plane. The Avro 730 was intended to be a reconnaissance plane and strategic bomber for the Royal Air Force, capable of Mach 3 flight and meeting the requirements of Air Ministry Specification QR.134D. The data collected from the Type 188 tests was less than promising. The maximum speed of the plane failed to meet the Mach 2 goal. Additionally, the 188 suffered from fuel leaks and limited endurance of around 25 minutes. Had Avro Aircraft's plane entered service, it could have become the United Kingdom's primary airborne nuclear bombing platform. It would have served as a nuclear deterrent and replaced the V-bombers. At the beginning of 1957, that year's White Paper on Defense was released, profoundly affecting the Avro project. The publication set forth the considerations and preoccupations of future British military development, goals, and strategies. In it, the Minister of Defense, Duncan Sandys, established the newfound promise of missile development. He also noted that Soviet anti-aircraft weaponry could make most crewed aircraft unsuitable as a primary line of defense. The aircraft industry was deeply affected, and the White Paper was followed by many layoffs and mergers pushed by the British government. That same year, the Avro 730 was cancelled, seemingly in an abrupt move. Several other manned aircraft projects in the United Kingdom were canned as well. By then, the military and government were under the idea that the country's financial state should be prioritized and that the missile age could render bomber aircraft semi-obsolete. Surface-to-air missiles now threatened all planes. Air combat would no longer be fought between nuclear bombers and fighter planes. Furthermore, the spark of the space age had demonstrated that missiles could be launched and hit anywhere in the world. From Soviet Russia to the United Kingdom, it wasn't that considerable of a distance. Uncertain proposals. There were multiple proposals considered to keep modifying the 188 in an attempt to create a more successful model. Recommendations included exchanging the engines for ramjets or rocket engines or adapting the plane for fighter or reconnaissance variants. Another plan suggested including wedge-type intakes. None of these ideas materialized. All development was halted and terminated in 1964. By the end of the most expensive research program for aircraft in the United Kingdom, each of the planes had to undergo cannibalization and the removal of components to keep the airframe ready in case of future flight. Mergers and cancellation. It must be noted that Type 188 was the Bristol Aeroplane Company's last plane. The publication of the 1957 White Paper on Defense changed the landscape for military aircraft development. The late 50s and 60s were marked by mergers of small companies and the cancellation of aviation projects deemed too costly or insufficiently protected against anti-aircraft missiles. Missile development, on the other hand, boomed. The company would merge under government pressure with Vickers Armstrongs, Inglis Electric Aviation, and Hunting Aircraft in 1960 to become the British Aircraft Corporation. All subsequent projects were developed under this new group. As for the surviving 2 flying pencil planes, they were never used in combat. In April of 1966, their fuselages were sent to the Proof and Experimental Establishment in Shoeburyness, Essex. There they were used as targets for gun tests. In 1972, the Type 188 model XF926 was dismantled, with its engines removed, and sent to the Royal Air Force Cosford Station for study as an instructional airframe. It has since been preserved by the Royal Air Force Museum, Cosford. The other Type 188, model XF923, was sent to Fellness Island for scrap.